All right, kids, here we are, day 3. Sorry about the delay on getting the video posted. Major technology issues this morning with Screencast-O-Matic, which is the website that I use to record all of this stuff for you. And then it easily, and I mean really easily, uploads to my YouTube channels, and that's why I use it the most. So I had to do a lot of restarting and re-downloading of things today. But again, we went through the slides pretty quickly, and there were some good questions in class. But again, we're talking about ecosystems. We're in the introduction of ecosystems, and it's important that you are able to identify the different factors. Now, just because I use this word here, I don't want you to get caught up and think, oh, he only means the biotic and abiotic. No. I mean all of the factors in an ecosystem. You need to be able to identify the carnivores, the omnivores, the herbivores, the producers, the consumers, the decomposers. You need to know what a community is. You need to talk about the carrying capacity. All of those things are factors in an ecosystem. You need to understand why and how they interact. And that's very important as we move through this. Again, we know that an ecosystem is all the living and non-living things, but the cool thing is, over the last little bit, you've learned 2 new words here for the living and non-living things. For the living things, you've learned that we call them biotic factors. Now, the important thing to understand is the biotic factors can be very similar. Now, if we're looking at a taiga and in a forest, you might see some very similar creatures, wolves and bears and owls. However, if we're comparing let's say a rainforest with the Arctic, you're going to see very different biotic factors. You're not going to see all of the insects and the bats and things in the Arctic that you would in a rainforest. So know that the living portions of an ecosystem, they can be similar, but they can be very, very different. And oftentimes it's the biotic factors that make an ecosystem very unique. We all know that you're not going to find polar bears in North Carolina, which is you'll find in a deciduous forest. You're not going to find polar bears in a rainforest. You may find polar bears, however, in the Arctic and in the taiga if they come down that far, and they do every once in a while. But we know that we would be looking at the Arctic to find polar bears. Conversely, we know that we're not going to find some of the snakes that we find in the jungles and the rainforest. We're not going to find those in North Carolina. We're not going to find those in the Arctic. So some biotic factors really do make ecosystems very, very unique. We know that there are abiotic factors, and the abiotic factors are in every ecosystem. Your sunlight, your temperature, your water, and your soil, yes, the rocks too, are all very unique. For example, if we were in a desert, I guess depending on which desert it is, but just a typical desert that we all think about, that very intense sunlight, very high temperature, the soil is very sandy, and the water is very low. There's not a lot of water there. However, if we come to North Carolina, we have varying amounts of sunlight. It changes from season to season. We have varying amounts of rain. That changes from season to season. Our soil, although it remains the same, it's very good soil for growing. And then our water is going to fluctuate, but we have way more water than a desert ecosystem. So abiotic factors really do, they, in conjunction with the biotic factors, really do make ecosystems very, very unique. You've already taken the quiz. You've watched the videos. We talked yesterday about producers for the first time, and we know that producers are plants. And the reason why they are so unique is they produce or they make their own food. We talked about if we go to the grocery store and we go to the produce section, we're going to see a majority of the things in that section, potatoes, carrots, all of your herbs and spices, celery, lettuce are all producers. They're all plants, and they make their own food. We talked about consumers. And I know that people got confused with this because it says if it eats plants, if it eats other plant-eating animals, or if it eats both. Basically, if you eat something, you are consuming something. You are consuming something, which means you are a consumer. Now, depending on what you eat, that is how you are defined. So consumers are defined by what they eat. We have 3 types of consumers: herbivore, carnivore, and omnivore. Now, let's look at this. Herbivores. Herbivores are consumers that only eat plants. They only eat producers. And that's all that's in their diet. So the sunlight gives the energy to the grass then gives its energy to the rabbit, to the cow, to the sheep, and the horse. That's how that works for them. And we'll get into the food chains pretty soon. But you'll notice how it's going to start kind of going in a chain like that. So we get from the sun to the grass as far as energy. Then the energy from the grass is going to go to an herbivore. So herbivores only eat plants. We talked about carnivores, and we said carnivores only eat meat. Your sharks, your snakes, spiders, eagles are all carnivores. The only thing they consume is meat. Then we take a look at our omnivores. Your primates, your bears, your humans. Most humans are omnivores. That means we eat a little bit of both. Because I meal prepped this week, I have the same lunch every day. I'm eating a salad, it's kale, with chicken on top. So I'm eating a plant, a producer, kale, and I'm eating meat, which is the chicken. So I am an omnivore this afternoon. We talked about two other things, scavengers and decomposers. And although they are consumers, they do eat things. It's kind of hard to really place them into one of those other categories. So they kind of have their own little category of their own. And we all know what scavengers are. We've seen them, right? You see the smushed squirrel in the middle of the road, and there's like 3 or 4 birds eating away at it. Those are scavengers. They eat the meat, the bones, the organs of dead animals for energy. And they're very important. If we didn't have them, what would happen is that dead stuff would just be there, and it would really take down the life expectancy of almost everything in the ecosystem. You can't have dead material lying around. It's not healthy to have that. We need something to break it down, and scavengers and decomposers do that for us. So once this awesome buzzard has eaten a giant portion of, let's say this is a dead deer on the side of the road, there's still some bits and pieces of it left over, and that's where my decomposers come into play. Bacteria, which are microscopic, you can't see them, that's why that picture's here. You have worms, and then you also have fungi, which is listed right here, fungi. Those are mushrooms. It's important to know that they take dead plants and dead animals and they break them down. They release the nutrients and the minerals that are stored inside of them back into the atmosphere and into the soil. And when you have something decomposed and it's broken down and decomposers are in the area, the soil in that area is very, very rich. When we come back to school, I'll see if I can find it. There's actually a bag of nothing but earthworm poop. And it's fantastic to put in your gardens because it really helps get everything growing because they make very rich soil. And so you might find some of those things, and it's called compost. Well, if you notice, most of that is right here. And we'll talk about prefixes, suffixes, and other words when we get back into class. It's a little easier to do when we're in class. We moved on today. This is what the new stuff is. This is where you might want to spend a little bit of time to community. Now, we know that an ecosystem is made up of living and non-living things. If we only studied the living things in an ecosystem, the living things, we are looking at a community. So if you're talking right here, here's one individual fish. If you counted all the fish in an area, like in a lake or a pond, you would have the population. We are going to look at all of the fish, all of the crabs, all of the tadpoles. This looks like a jellyfish, but that certainly wouldn't be in a lake. Maybe that's in the ocean. All of this is all the living things, and you could even count the grass because that is a living thing. Those are all living things in one area, and those are made up the community. Now here, when we start getting down into the ecosystem, we're starting to count things like the water, the rock, I hate that, but it's there, the sunlight and the temperature to make up the ecosystem, and then we'll get into why we make up a biome and then the biosphere later on in ecosystems. The last thing that I covered today was something called carrying capacity. Carrying capacity is extremely important. And I can explain it, and I like to explain it, if we look at the woods behind Friendship Elementary. If I had 2 bears that wanted to live out there, they would have enough food, they would have enough water, they would have enough shelter, and every other resource that they would need to coexist and live in those woods. There would be no problem whatsoever. The forest out there can hold, it can carry 2 bears. We could even argue that 3, 4, 5, maybe even 6 bears could fit out there in the woods, and they would still have enough resources, shelter, food, and water. They would have enough things to keep them alive. However, if we put 100 bears out there, the forest cannot carry. It cannot carry or hold that much. That small ecosystem would collapse. There's not enough resources. Very quickly, they would eat all the food. Very quickly, they would consume all the water. Very quickly, they would run out of shelter. And some bears would have nowhere to stay and to live. Each ecosystem has a very unique carrying capacity. If we look at this fishbowl, it easily can hold or carry 3 goldfish. Everything is working perfectly normal. However, if we add, 25 or 30 goldfish, we have exceeded the carrying capacity. And when you do that, it really does send like a domino effect down through the ecosystem, and it can really make a lot of things die. Now, typically when the carrying capacity is exceeded, animals realize that there's not enough resources here, and they will move to where there are more resources. But it can happen like this. Sometimes there's deforestation. People might come in and chop down a large area of forest, and the birds and the owls and the squirrels and the chipmunks and bears and deer and fox and rabbits and everything else, they move to another area, but the addition of them could exceed the carrying capacity of that forest. The animals are smart. They figure this out pretty quick. With all the competition going on for food, tons of predators and things like that, they're like, this is not a good place to stay. I'm going to move on to somewhere else. And the animals really do help keep things in balance as far as carrying capacity goes. At the end of this, I hope you'll get to go back in and do the time to climb. That's a great way to test your knowledge of the vocabulary words for this week. When you have finished everything in Nearpod, don't forget to go back into Mr. Bullen's classroom, go under Classwork, and there's a couple of things we need to take a look at today that you need to finish up. So I always go into the slides because that's where Mr. Bullen's puts everything. So I know I need to go down. I can skip down quite a bit here because that's Monday. There's Tuesday. Today is Wednesday. Should change colors for me to purple, I think. There we go. The Zoom was this morning. If you missed it, this is in place of the Zoom. The agenda for today is here. Hopefully, you can go back into Nearpod, clicking this link, and using your correct code. If you're in my homeroom, use this one. If you're in Miss Klein's, use this one. If you're in Miss Saunders, use this one. Go into Nearpod. If you haven't taken the quiz, which a majority of us have, if you haven't, go ahead and take the quiz. Go all the way through and do the time to climb, and you can take time to get those notes. And that's fine. We'll move down from here. I do want you to sign up for quizzes. If you click this and go to this link, it's going to take you to another page. It's going to look similar to this, although I think it's going to go ahead and log me in because I've already logged in. Sign in with Google. If it asks for your birthday, just put that in. You do not have to do this portion for your parents. I will do that for you. Accept the invite. That is all you have to do. There are no quizzes today. I'm going to show you tomorrow how to do the quizzes. And then finally, the last thing on our agenda today was to go into Flipgrid, and you have a prompt. And your prompt is, what is the big difference between biotic and abiotic factors? What are some examples of biotic factors and abiotic factors? And are the biotic factors and abiotic factors the same in every ecosystem? And you can see lots of people, lots and lots of students have made some fantastic videos. Make that video and submit it to me so that I can go back and look at it. And I think I'm actually going to grade these. I think it'll be one of our first grades, a very, very easy grade for everyone to get. So that is everything that we have to do for today. I will get this posted up to YouTube in just a moment. And I guess I have to end all YouTube videos with those famous words. Be sure to smash that like button and subscribe.